Dr. Lawrence W. Moore, and this is Learning Synthesis with Pure Data. This is a series of tutorials in which we're going to learn the art of synthesis and sound design using a software that's a free download and available for any operating system called Pure Data. Basically, this course is going to teach you the fundamentals of synthesis. Maybe you're a songwriter, composer, performer, maybe just make beats, and you use already a digital audio workstation software that has all these plug-in instruments in it. And these plug-in instruments have these elaborate graphic user interfaces with all these dials and sliders and knobs on it that are labeled, and you don't know what these labels mean. They say things like frequency modulation, amplitude modulation, ring modulation, attack, decay, sustain, release, LFO, and different things like that. And you're not quite sure what these things are, and maybe you know what some of them are, but you don't know what some of the others are. And this is a course where you're going to learn these things. And in this case, you're going to learn the fundamentals. So while we'll be using a different software here, you'll be able to utilize the software you already have or something new that you buy in the future, because they all speak the same language, and that language is synthesis. And so we're going to use a software called Pure Data, so that way we're both using the same thing, and everything will look the same for you and for me, and I'll be able to create some things for you for some tutorials and maybe some devices that we're building, and you'll be able to download them from me and everything. It'll just make the learning process easier if we're using the same software. Now, Pure Data is a great software to learn because it's an open source programming environment where basically you could design your own software instruments among many other things. But primarily we'll be designing our own synthesizers and software instruments that we can use in our own creations. And it's open source and free, so it's a free download for you, and it's not hard to install. And basically as we learn it, you'll be learning synthesis as well as the Pure Data programming environment, so you can build all sorts of things later on, even beyond synthesis. So anyway, without any other further ado, my assistant Crafty and I are going to help you get started now. The first thing we're going to do is to download Pure Data, and then we're going to install it, and then also get a little tour of it, and learn some of the digital audio and synthesis basics. So this is episode 1, and I'll see you at the end. Okay, so now what we're going to do is I'm going to show you some websites, and we're going to download Pure Data from, an official site, so that way you can feel assured that it's the software you're looking for without any other adware. First, I wanted to show you Miller Puckett's homepage. He's the creator of PD. I found this by just going to Bing, did a Bing search of Miller Puckett, spelled Puckette, and of course it's the first thing that came up. If it's not, just look for that link, Miller Puckett, without anything else. If it looks like this, that's his homepage. And he kind of keeps it nice and zen here, so you can kind of look through it to see what other things he has here. There, like for example, there are ebooks here that are free downloads that are very informative if you're interested in synthesis and other forms of digital audio, signal processing, and so forth. That's good text to look at. The next site I want to show you is puredata.info. That's here. This is the community of developers that, people that want to add things to Pure Data. Basically, Pure Data is open source software, meaning that other developers are invited to develop things for it, and of course use it and build things with it. And a lot of people meet up here at the puredata.info site, where there's a forum and a community. You see here, community, but also downloads, and that's what we're going to go to here. If you go to downloads, there we go. You see it come up here, and basically you can browse to the links and make sure you get something for your operating system. What we'll be using is called PD Vanilla, or Pure Data Vanilla, which means it's standalone, just Pure Data. Like here you see this, Pure Data Vanilla. And basically, you look for the version for your operating system and so forth. Windows users, if you see an exe version, you're welcome to download that and run it, but I'll show you how to work with the standalone version. And then Mac users, you do the same thing with you Linux users. So anyway, I'm going to download this. At the time of this video, it looks like the latest release is 0.46.7. I actually already have it, but I'm going to download it so you can kind of see how to use the standalone version in case it throws you for a loop. But anyway, here I clicked on that, and then I'm going to Windows, and it's downloading right now. Now I already have my downloads folder here so that I can open it up. Still downloading. So, there we go. Basically, this is a zip file version. Mac users, you may just get a PD icon here, or maybe it'll be in a zip folder. But basically what you do is you open the archive, and when you do, you basically can put this on your desktop, which I'm going to do now. I'm going to keep it here so you can see the folder structures that I use and everything. And so I'm going to put it here on the desktop. And then I'll close my software here as soon as it's done extracting. There we go. And so you get this folder that just says PD. Now Mac users, you probably just get an icon that says PD. Your standalone version can be opened up into folders as well if you right click on it and go to Get Info. But for you PC users, let me close my downloads folder. You open this folder and you see at the top there's a bin folder. This is where the executable is. As we go on with this series, I may talk about some of the other folders here and introduce you to them, but right now this is where you go to open the software, which is what we want to do right now. And you see in here the PD icon. It just says PD, and it has the icon, the black and white PD symbol. Basically, you double click that, and then probably, it just opens directly. If you get a message that says, hey, you're about to run an application and it's unknown to the system or something like that, if you downloaded it from puredata.info, it's safe to open, so you don't have to worry about it. But that's just saying you didn't install the software to the system. It hasn't been prior approved. What is this? And so you just gotta clear it. Mac users, I use PD in a lab situation. I'm not sure how it is on your home computer, but basically if you get a message saying it's not going to open it, you right click on it and go to open, and then it gives you the ability to say OK and basically give consent to open the software. It's all just because, it's a standalone version and your system doesn't know what it is. But it's, as long as you get it from puredata.info, you're fine. So now what I'm going to do is show you a little bit about the Windows here, and just to give you a little bit of an overview. And then before we close up today, I will show you a couple other websites towards the end of this video. Alright, so I'm queuing up my magnifier here so I can zoom in, pressing the plus button. Those of you who are Mac users, you'll see this PD window here as well, but your menu bar strip will be at the top of your screen like other menu bars in Mac. So here at PC users, you see it right on this window. Now this window is going to be a feedback window for you. It's going to give you some information at times, like any errors or problems that are occurring. You'll see them listed here. This is where you can kind of see some communications from Pure Data itself that's telling you some things. The main window we want to look at now is the media window, because in here this is where you can go to test audio and MIDI and make sure that you're getting sound, because we'll want to make sure we have sound soon. So we'll click on that, and basically we're not going to be doing anything with audio input, but you may see these numbers fluctuating here. That's just saying that it's receiving sound coming in from channels 1 and 2. I have a headset mic, and so me talking right now is registering some information here. It's receiving amplitude. So these others are not showing anything because I don't have channels 3 through 8 on a headset mic. Just 1 and 2, which is like left and right. It's a stereo microphone. Over here, this is where you test your output, which is the main thing we want for now, because we're not going to be doing anything with input just yet. But anyway, you want to click on either this or this button, and you can hear from my system you get a tone. That's your test tone to make sure sound is coming out. If you're not hearing sound coming out, you'll want to go to the media menu again. Now that this is open, you have two media menus. Either one is fine, because this PD window is associated with this, because this, what we call a patch in pure data terminology, has been opened with this window, so these are considered basically menus that affect the same thing largely. And so here in the media menu, you'll see, and it should be automatic, that DSP on is checked. That simply means that audio is on and it's flowing. This calling up this patch to test your audio and MIDI should automatically turn it on. But when we start working soon, we'll need to turn this on and off manually. And so we'll pay attention to this later. Right now, down at the bottom, you see a menu for MIDI settings and an option for audio settings. Click on audio settings, and what it gives you is a window where it shows you input devices and output devices. Output devices are what we're really kind of concerned about. You can click this and it opens up to display your different audio devices, or at least valid output devices. If you have speakers built into your computer, that's fine. We can use those. Or headphones. Just using your standard built-in audio is probably good to start with at first, because it's most likely going to work just fine. The other stuff will probably work later, but until you get used to PD, this is good to go with. And so this is my headset thing, and I heard sound, so I don't need to worry about this anyway. But that's just something to check if you didn't hear sound, just to make sure that's set up right. And then you press OK. Now remember, I said I was going to show you some other sites as we go. If you're not getting sound very well, go to a Google search or a Bing search for something called Floss PD Manual. I'm going to open up my browser and show that to you. That's right here. Basically, if you search for Floss PD Manual and you see a result that says Floss PD Manual, you click on it, you'll get here, or you'll get to the main Floss site that says Floss Manuals. Either way, you're at the right general location. You just want to go to the PD manual. And over here on the left, you'll see basically some instructions and stuff, and toward the top, let me browse down a little bit here, you see instructions for different operating systems for installing PD. And so this is a good place to check. It'll give you more instantaneous results if you need help installing it or something. In my findings, probably by now everything did work for you, so we don't have to worry about it. And I'll show you my site later. So anyway, we'll put that down just in case you're having a little trouble. There's a lot of troubleshooting there that's pretty easy to go through and solve your problems quicker. Alrighty. So anyway, it's also a good manual, I guess, to look at if you want to look at some other topics, because they also do go through a lot of learning PD stuff. So I'm going to put my magnifier down here, and we're back at the PD menu. What we want to do, I closed that test audio and PD menu, but what we're going to do is open up a new patch window. And simply you go to the file menu and you go to new. And this gives you what we call a patch window. And basically everything that we make in PD is generally called a patch. It's like a document for Word. Word documents are called documents, and that's what you use Word to make. And same thing in PD, you make patches in PD. That's just what they're called, and it comes from the terminology of the days of connecting hardware devices together, like synthesizer modules and so forth, using patch cables, connecting things together. And that's what we'll be doing. we're basically going to make a simple little sound generating synthesizer here. Extremely basic, but it's a way to get started and learn, how PD works. So what we're going to do first of all is save this patch. So you can see that it saves to files, and that's a file you can open later when you want to open up the patch you made. So I'm going to go to Save or Save As. It'll make sure to give you a browser menu to locate where you're going to save it. I'm going to go to the desktop. I'm going to make a new folder here on the desktop. Let's see here. Is there a new folder icon here? Create new folder. There we go. And I'm going to call this Learning Synthesis with Pure Data, the name of this series. There we go. And then I'm going to click it to save this in here. And what I'm going to call this patch, now since I'm going to give it a file name now, I'm going to tell you, let's get into the habit of making file names that are just all lowercase, because later we want to use some of these files to open up within other patches, and you got to follow some rules in naming them to do that. Lowercase file names is not a steadfast rule per se, but file names are case sensitive when you're using them with one another in Pure Data. So I just follow the general rule of thumb of using all lowercase file names. So we're going to call this basic, and I'm going to show you the other rule. You don't want to use any spaces in your names. And I'm going to put a dash there because I want to type basic synth. That way you can use things that are multiple words and you don't put a space in. Because basically if we want to load this patch into something else, and we will be doing things like that as we go, you cannot have file names that have spaces in it. So let's just get into that habit. When you save patches, use lowercase, use dashes or underscores for spaces. Okay, so now what we're going to do is we're going to make a simple little synth, extremely simple, just so we can hear sound coming out. And what I'm going to do first of all is go up to the Put menu here, go down to Object, which is the top item in the list, and you notice here for each of these things in the Put menu, these are the things that you put in your patch to build things, and each of them has, well, except for these two at the bottom, each of them has a shortcut keyboard command that you can use to call them up in the future. Eventually we're going to start using these just to be quicker, and we want to make an object, so I'm going to select that for now. And when you make an object, you'll see it's this little highlighted box, highlighted blue, and wherever you move your mouse cursor, which is a hand right now, the object goes with you. If you left click, the object goes down, and that's basically placing it. If you left click it again and drag, left click it again, actually it wants me to name it. Okay, never mind that. Let's left click it again to make sure the mouse cursor's in there, and we're going to put in an object name so this becomes a working object. Now we're going to type OSC, then after OSC we're going to put the tilde symbol. The tilde symbol, in case you don't normally use it, is just to the left of the 1 on your number strip, the horizontal number strip that's up towards the top of your keyboard. Just to the left of that, there's a key. If you hold down the Shift button and then press that key, you'll get a tilde. Looks like that. It's part of the name and you need to have it. Then we're going to make a space. We're going to type the number 440. And then what you do actually is click outside the object with your mouse, left click, and now it made what we call a valid object, because there is such a thing as an OSC tilde and accepts the number 448 right after it. If you see this, for example, I'm going to quickly make a mistake here and type OSC, and I'm going to forget the tilde and click And I could even put space 440. And then if I click, you see it doesn't complete the box. This is considered an invalid object because it doesn't recognize it. And over here it says couldn't create in red in the PD menu. That's where the PD menu comes in, or excuse me, the PD window. It basically tells you errors that happen. So I'm going to drag, select, and delete this because I know what I'm doing and I know that that is invalid, but I wanted to show you. So if you see something like that, the idea is you got to type it right. So anyway, OSC tilde space 440 is a valid object, and what it basically means, OSC tilde is an object that is a sine wave oscillator. And then the number 440 is information that goes with it. In this case, it is its frequency. In other words, if we connect this up to, well, we're going to connect it up to an object afterwards here, and we'll hear a sine wave tone at the pitch A440, which means it's 440 hertz. It's one of the frequencies out there that is a round number, and also a valid note in our Western tuning system. So I'm going to create now another object. You can go to the Put menu and down to Object, but I'm going to start getting into the habit here of using the shortcut Control 1. This was Command 1 in Mac. Alright. Basically, the shortcuts in PC are the same as in Mac, except use Control in PC and Command in Mac. So I'm going to click here and type DAC tilde, and then click outside the object box, and you see it completes itself. Now what DAC is it means digital to analog converter. That means we can put sound into this and it comes out our sound card. Because your sound card, basically, its output, the headphone jack on your computer or its speakers are basically converting a digital signal from computer software into an analog voltage signal, which makes the speaker vibrate and create sound. And so it's called a digital to analog converter, or DAC. We'll just say DAC for our purposes here. Now, if I connect this OSC up to here, we can hear sound. We won't hear it right away, but I'll show you what to do after this. But we want to connect this. And in PD, when you want to connect objects together, or different items together, you go to the bottom, these dark spaces here, which are called outlets. Anything on the bottom of an object is called an outlet, because sound comes out of here, or information comes out of here. In this case, it's an oscillator, so it is sound that's coming out of here, virtual sound. And we can go down here to the top dark lines on the DAC, connect it up. You see it makes a circle there. That means, okay, you can connect it. Okay, and I hear sound already. And actually, it's annoying, so I'm going to turn it off. Let me go up to the Media menu and go to DSP off. Remember, I showed this to you before. Basically, in the Media menu, you have, at the top, DSP on, DSP off. That turns sound on and off. And it has shortcuts. Control / for on, Control period for off. These two keys are right next to each other on your keyboard, so it's a good habit to get into to turn sound on and off with those shortcuts. We heard sound coming out our left speaker, and we heard it coming out pretty loud. That's why we turned it off. If we connect up this outlet also to the right inlet on the top of DAC, we would now hear sound coming out the right speaker. Alright, let me turn it on and then off quick. There you go. So it comes out both speakers. Basically, your DAC will have any number of inlets on the top of it for the audio device you have selected in audio settings, right here. Since I have a stereo headset on, it's just left and right, because it's a stereo headset, and you see here it has two channels, left and right. Okay, and that's probably what you have for any built-in audio. If you have some sort of 5.1 system there, it'll show 6 channels. Or you can set it to have 6 channels if it doesn't already say that. Okay, so here we got some basic sound already, and now what we're going to do is actually control this a little bit, because right now it's making some loud sound, and we want to be able to control the loudness. So actually, before we do that, I'm going to show you a way so you can visualize what's happening. Basically, if we go to the Put menu here, we can select something at the bottom. Doesn't have a shortcut, but it's called an array. And then once you click that, you get a window that opens up. I had to scoot over to it because it came up to the side. Incidentally, sometimes windows may come up in PD when you're like creating an array like we did, or maybe your PD menu appears somewhere, your PD window appears somewhere not quite on screen. Sometimes you have to look for them. And so when you create an array like that, just look around for this menu. It may sometimes be behind like your PD window here or your patch window. It's good to kind of move those around and look for it if you're not seeing it. But anyway, this menu that comes up has two options at the top that I'm going to show you right now. The first option is name, and this actually is where we're going to type a new name for it. By default, it'll say array and then a number afterwards, and since this is the first array we made, it says array 1. And then, of course, if you made a second one right after, it would be array 2 and so forth. But I'm going to call this, instead of array 1, display. D-I-S-P-L-A-Y. Now, you can name it whatever you want. I encourage you to just name it display. But the one rule you do need to follow, just like in file names, things are case sensitive. So I like to just always use lowercase. And you can't have spaces in the name. Otherwise, it won't be found and won't work right. So right now, display is fine. So I type that and press OK. And then we have an array right here. Now I mentioned there were top two options there in that menu we just saw. We can get back to that menu by right-clicking on the array and going to Properties. That happened really quick there because my mouse cursor was right over Properties. And actually this time we get two menus. The first one is the one we saw before with our name. And then there's an option for size. It's set to 100. We're going to keep it at 100, but I wanted to point this out to show you what it means. Let me move this right over here. Okay. Basically, let me try to get all this right in the same area if I can. Well, we don't need to see the bottom half of that, so I'll move that there. Okay. So, 100 is shown here. In the second menu, which we're not really going to use right now, I'm just going to point out, at least down here towards the bottom, you see there's something called X range from 0 to 100. This basically should coincide with the number here. And what this means is our x-axis has a range of 0 to 100. And literally, this line here is really a series of dots. And there should be 100 of them. Well, in this case, I guess technically 101. If the first one's 0, and then it goes up to 100, that's a total of 101 dots. So basically, you have these dots here, but since they're all on the same level, they look like a line. And basically what that means is we have 100 different values that we can store in this array. And literally what this is going to become is like an oscilloscope where we'll see a waveform. But in digital audio, everything is numbers. And so basically all our waveforms and stuff are going to be made out of numbers. And we'll see that happen in just a little bit. But let me also point out to you here, the Y range, that's the vertical range, is from 1 to -1. And everything starts from the perspective of the top left corner. Your Y range is from +1 down to -1, and there's 0 in the middle. And then you have 0 to 100 here in the X range, 0 to 100. So on the X-axis, it's left to right, 0 to 100, and the Y-axis, top to bottom, it's 1 down to -1. Okay, I just wanted to point that out. These are things that can be changed when you make arrays for different purposes, but right now we want this. So we're going to press OK and leave everything as is. I just wanted to point that out. Now what this array is something that can contain numbers, and in digital audio, your sound that you're producing is really numbers while it's in your computer. And so what we're going to do is take the sound from our oscillator and display it over here. And the way we can do that is by making another object. I'm going to use the shortcut now, Control 1, Command 1 in Mac. Put an object there and type tab, T-A-B, write, W-R-I-T-E, tilde. And I'm going to put a space. And right after that, I'm going to put the name of our array, which is display. Click outside the object, and it accepts it. We're fine. Now, I can connect this oscillator up to this tab right object by connecting the output here to the input here, or the inlet here. And now, sound signal is going to this object. Now, we don't see anything display yet, well, really for two reasons. One, we haven't turned DSP on, but let's not turn it on just yet. But also, two, we didn't send a signal to tab right to tell it to write. And that signal that we send to it is a signal that's common in PD for lots of different things. In the put menu, you go about halfway down, well, a little bit above halfway, and you see bang here. Its shortcut is Shift Control B or Shift Command B in Mac. And what it gives you is this little square and an outline of a circle in the middle. This is called a bang, and it has an outlet on the bottom of it that you can connect to tab right. Now you notice how the line from the bang object here is thin, and these lines here are thick. Basically, that's because the signal from the bang is what's called a control signal, or it's something that operates in the normal keeping of time in PD called milliseconds. 1,000 milliseconds equals 1 second. And basically, things with thin lines operate like that. Things with thick lines are audio objects, digital audio, that carry signal. And sound signal for digital audio needs to operate at what's called the sampling rate. Up here in the media menu, if you go down to audio settings and you look up top here, you see there's something called sample rate. And this is something you probably heard of in audio, but I'll just go over it briefly. 44,100, the CD standard audio sampling rate. That's what it'll default to usually, and unless you have audio hardware that is locked to some other sampling rate. And I'm going to press OK because I don't want to change it. But that's what it's talking about. That means there's 44,100 samples, or really numbers, per second, because that's what needs to be traveling per second in order to keep up with the sampling rate, which allows you to keep fast enough waveforms in order for you to hear sound. We'll go into some of those principles later, but right now I just want you to know the difference between the audio rate stuff, which you can think of right now as carrying sound, like sound from the oscillator to the speaker, sound from the oscillator into tab right. And the other thing about audio objects, those are the objects with these little tildes behind them, like DAC, tab right, and OSC, which stands for oscillator. Basically, anything that deals with audio has a tilde after its name. And basically, the bang here is just a graphic object, so we don't see a non-tilde after its name. Although, I think if you create an object like this and just type the word bang in there, click outside, alright, it makes a bang object, it accepts it, and although really, it's better to use this or a message object that we'll talk about. But as you see, no tilde. Okay, so now, what we need to do, I'm actually, just so we don't hear the sound, I'm going to disconnect these patches here. That way we don't hear this loud beep in our ears. But we'll see it. We'll see its effect here. Now, this time, after I turn on DSP up here, we see nothing happens. What I need to do next is go into what's called run mode, because we need to click this bang here for tab right to get a signal to write. And so what I'm going to do is go over here to the edit menu and just show you. Sorry. As you see from edit, down here at the bottom, there's an option called edit mode. And there's a shortcut control E here, which will be good to memorize. Command E in Mac. And you see it's checked off. Well, I'm going to click it so it unchecks it. You see now my mouse cursor is an arrow. This means we're in run mode. It doesn't say it in that menu, but it means edit mode is unchecked. It's basically the opposite of edit mode. And what that means is you have an arrow mouse cursor now, and now you can use things and click them on screen that are graphic controls. And that's what we need to do in order to click this bang and have it actually bang. There we go. After sending that bang signal here, we now see a waveform display. Basically what we did is just like a camera, we kind of clicked its button, its shutter button, and it took a picture or a snapshot of the sound signal coming in and gave us a snapshot. And this snapshot is basically 0 through 100 of the x-axis here, and it's showing us how these dots are going up and down in a smooth sine wave shape. And basically each one of these dots is like a number in the y-axis. So you could look at the coordinate of, let's say, okay, dot number 1 is what? Well, it's something near positive 1 up here. Okay, so it's maybe 0.987, something like that. Because all the numbers in between 1, 0, and negative 1 are decimal numbers, and they could have a lot of numbers after the decimal point, like 0.98325, whatever, or 0.74321, It's basically a series of numbers that gives a more accurate number between 0 and 1, or 0 and negative 1. And that's what each of these samples is. It's a number in this range. This range is called a normalized range. It means 0 to 1 as maximum and 0 to negative 1, which you could think of as maximum, but just in the downward direction. Because basically the thickness, or actually not the thickness, but the width from which a sound wave goes out from the center, which is 0, it is said that that is the larger in amplitude. And so amplitude is directly related to how loud we will hear the sound. So we're actually going to work with amplitude right now, and we're going to give this thing some volume control. But the first thing I want to do, since this is like a camera that takes picture after picture after picture, I want to set this up so it continually takes pictures, so we see kind of like an animated view or a continuous view of the waveform oscillating. So I'm going to go back to edit mode. I'm using the shortcut Control E, and you see we get the hand again as our cursor. And I'm going to make another object here. Let me move this array over. You can click on it in edit mode and move it. I'm going to make an object called Metro. I hit Control 1. Sometimes it'll put it like automatically at the bottom of the last thing you made. But here's its empty object box. I'll click in it, make sure we have the cursor there. And I'm going to type Metro. No tilde, space, 100. And I'll explain that in a moment. But now I can click here, and we have it. Now I'm going to connect the bottom outlet of Metro 100 to the bang. Move this over there just to be nice and precise. Don't have to worry about it, but I do. And the next thing we're going to make, well, actually, let me just explain Metro and then I'll go to that. Metro sounds like the word metronome, and really it is an abbreviation for that. And just like a metronome clicks at a tempo, the Metro object sends bangs at a tempo. So it keeps shooting out these bangs, which is the same as the signal that's sent by this object called a bang. And basically you can connect it up to a bang. A bang will receive a bang and just pass it along. And basically what this will do is continuously send bangs, so this tab right object continuously takes pictures of the waveform coming out of oscillator and puts it here in our table or array. If I use the word table or array, I'm referring to the same thing over here. For the most part, those words are somewhat interchangeable. For at least what we're doing now, they are. So sometimes I'll say table, and sometimes I'll say array. Okay, so now basically what it is an array is a type of table. Anyway, I'm going to go here to put, and we're going to put another object, and it's called toggle. Because right now for Metro to work, we need to turn it on. And what Metro turns on with is either the number 1 being sent to it. Well, actually, that's what turns it on, the number 1 being sent to it. And the other option is you could send a 0 to it to turn it off. So you have an on switch and an off switch. The toggle object is exactly that. You connect it like this by connecting its outlet to the left inlet of Metro. As we go on, I'll explain these other inlets, at the top of these objects. Like you see a right inlet here, and a left inlet here we're so far not using. We'll get to those. But anyway, this toggle now will allow us to see the waveform get displayed because it'll turn Metro on. But we have to go into run mode again to do that. Remember, that's Control E or Command E in Mac. And you get the arrow key. You're in run mode. Now you can click and do things, just like we were able to click a bang before, and you see it updates again. Well, now we're going to turn on Metro, and it'll continuously bang. By setting up Metro with the initial value of 100, basically what we're saying is every 100 milliseconds, send out a bang. And you see our bang is lighting up pretty quickly here. 100 milliseconds is a bang every tenth of a second, basically 10 times a second. 1,000 milliseconds equals 1 second. 100 milliseconds equals 1/10 of a second, or 0.1 seconds. Basically, it'll be banging every tenth of a second. So basically 10 times a second it's updating the table and basically writing our waveform. So it looks like a continuous picture almost. And what these are these samples. There's 44,100 of them per second streaming out of oscillator here. And they're oscillating in a wave shape going up and down, up to 1 and down to -1, 440 times per second. So that's what your frequency in hertz is. 440 times per second the waveform is oscillating up and down. Basically, let me stop right here. Basically, a full oscillation, or what we would call a full cycle of the waveform, would be the middle of the top or the crest of the waveform. Well, not the middle of it. Actually, usually you start where the waveform starts, goes up, right at the 0 line. It starts here, it goes up, and really here it's wrapping around down here to the bottom, then back to 0. Let me see if I can click this in a way that we get this, what we call in phase. That's close. That's basically in phase as what we would actually call a cosine, I guess. Well, anyway, here we have starting at 0, going down, and then going up, and then ending at 0. This is a complete cycle. This is basically a circle unwrapped. And so when you have an unwrapped circle like this, it's basically because time is going forward and the circle can't, wrap up and complete to be a circle because time keeps going forward. So it's kind of like a circle unwrapped over time. And it's made up of samples. Our table only displays 100 samples. And since there's 44,100 of them being produced every second, if we have a 100 sample size table and take a picture every 100 milliseconds, you're roughly going to get, capture a good picture of a cycle at the speed of 440 hertz, because your sampling rate is 44,100 hertz, which is just a little bit higher than 100 times 440. That would actually be 44,000 even. But sampling rates are actually, the sampling rate is 44,100. We can get into why the number is later. But right now, let's do this. I'm actually going to change this from 440 to 441. And now let's just see here. Now when I take pictures of it, from here to here, we do see a complete cycle. It just depends on where the cycle starts and ends on the left and right side. And that would actually be called phase. There we go. That's almost, you see it's just a little bit below the zero line here. And same thing where it ends up. So it is at least starting and ending in basically the same place, because now our hertz is exactly 1/100th of our sampling rate. And since it's 1/100th and our table size is 100, we'll see complete cycles here. Just a little FYI there. If you don't quite grasp that at this point, don't worry about it so much. It's it's not really important. The main thing to know is, okay, oscillator's oscillating 440 times per second. You'll see 440 complete cycles of the waveform per second, where if you don't see it, it's happening. And that gives us the pitch A440, which sounds like the tone we hear that we've been turning off because it's annoying to hear that. So actually, let's conclude this with 2 more steps, and that'll be our first lesson. I'm going to go back to edit mode and just move this down just to kind of give it a little bit more space here. This bang here, I actually don't need this, because bangs come out of the metro, so I could connect it straight to tab right like that. And I can delete this bang, and you'll see if I go back into run mode, it'll animate just fine. We don't need the bang there, and we don't see this thing flashing there anymore. Since we don't need it, might as well go without it. Sometimes I put extra things in, for reasons, but if there's no reason to have a bang there, I'll take it out. If you want to see it blinking away, then fine, you can leave it there. Now what we're going to do, the sound that comes out of the oscillator fluctuates between 1 and -1. It's what we would call a normalized waveform. Basically, it's fluctuating or oscillating between the maximum values for getting signal in digital audio that's not distorting. If you go above 1 or below -1, the sound actually starts distorting, because it's basically louder than it should be for your bit resolution. And we don't need to go into all that detail right now. Let's just at least say, okay, going above 1 and below -1 is not good. And so what we'll do here, we do want to, however, set up something so we can control volume or loudness or amplitude. Basically, really we're controlling amplitude, but we'll hear it as volume control. And what we're going to do to do that is we're going to make a multiplier object, which is making an object, control 1 or command 1 in Mac. Then you put in an asterisk, and since this is sound, we're going to put a tilde after the asterisk. And that's all we're going to put. Basically, what this is this is a multiplier that will take all the numbers coming out of here. And those are numbers that are fluctuating between 1 and -1 in a stream. A stream of numbers is what sound signal is in the digital world. And so we're going to take these numbers and multiply them by another number to reduce them. And basically, you could think of the number that you multiply them by as being like a percentage. For example, if we multiply them by, now what I made here is a message box. So let me show you that. The put menu is the second one. Control 2. And this allows us to send messages to other things. Messages can be words, or in this case, numbers, because we want to send a number here to say, okay, take these sound signal numbers and multiply them by this number. And the number we're going to make is 0.5. And we'll connect this up here to the right inlet of the multiplier. Basically means numbers coming in here. Since it has a tilde, it's expecting that these are coming at the audio rate. Multiply it by 0.5 coming in here, and output the result here. Ooh, I was going to put it into DAC. Not just yet. Let's put it here into tab right. Now I'm going to go to run mode, Command E or Control E. Click the toggle to turn on Metro. Now right now we see nothing because we made this multiplier object and it basically multiplies it by nothing at first until you send the 0.5. So I'm going to click this message box here and it sends the 0.5, and now we see our tone fluctuating from between 0 and 0.5 and negative 0.5. So we basically cut its amplitude in half. It's no longer going to 1 and negative 1. Everything's being multiplied by 0.5, which is the same as multiplying it by 1/2, which basically makes it half the value it was. So all these numbers streaming through are now cut in half, and we basically get a quieter amplitude. Let's hook it up and hear it, and you'll hear that it is quieter than it was before. Still loud enough to be annoying, so we're going to go up here to Media, DSP off. Alright, let's make it even quieter. I'm going to make another message box. I'm going to use the shortcut Control 2 or Command 2 in Mac, and we'll say 0.2. How about that? Now we're basically going to make it 20% as loud because 0.2 is really 20%. And I'm going to turn on the DSP, and then I'm going to click 0.2, so that way you'll hear the louder tone, and then you'll hear it get quieter. And there we go. Now if we want to turn this off, let's quick make a message box that has a 0 in it. And so I'm going to connect this up real quick. Here. And click it. There we go. It turns it off. Now everything's multiplied by 0, which means nothing. And so there's 0 amplitude. You don't hear it. Okay. So that's a little bit of basics here. I'm going to show you one last thing. There's easier ways, and in the next lesson we'll see an easier way to control volume and something that's a lot more user-friendly than clicking message boxes with a single number in them. I just wanted to explain the concept, the math behind, what amplitude is and how digital audio works in that way. I'm going to go into edit mode here, and I'm going to add another thing. Let's make another message box, and then let's type in the number 220. And then I'm going to connect this one up to the left inlet of OSC tilde. The left inlet of the oscillator object, which oscillates a sine wave, is where you send frequency numbers. When we made this object, we immediately typed 440. It accepts that as the starting frequency that object will be, the oscillator object will start at. But if you send other numbers in here, it changes to those frequencies that you send in. And these frequency numbers are frequency in hertz. So I'm going to go here into edit mode. I'm going to turn on DSP here. Oh, it is on. We just need to click this 0.2 so we actually hear sound. Oh, that's the 0, sorry, 0.2. And so we hear this tone. Now let's hit 220. And now what we're hearing is a tone that is cycling at 220 hertz, or an octave lower than 440. So basically, let me turn sound off to explain it. So basically now you see actually the cycles are wider. That's because there's fewer of them per second, so they take up longer lengths. Because a single second is 44,100 samples. It would basically be like this table extending off into the distance. And Basically, you would have 220 cycles or waves, complete cycles of the wave in that space. 220 of them. Yeah, it's a pretty big space. So yeah. And in case, if you have 440 of them, obviously there's more of them per second, which means they're more bunched up together, and they have shorter, what we call wavelength. And so, basically, that's the science behind that. Any frequency that's half of another frequency is going to sound down what we call the octave. And the octave is a strong relationship in music. It's something that, in fact, when we have tuned notes and everything like A440, this is A220. It has the same name, in fact. Just a different hertz because it's an octave lower. We can make another message box here and make this 880. Click outside. Connect this message box up to the left inlet. And now what we're going to do is we can send 880. And actually, if we want to go back to 440, what we have to do now is send 440 in there. So I'm going to make another message box and make it 440. Because this initial number, after OSC tilde 440, that's only a starting number. As soon as something else is sent, that number's no longer relevant. So now I'll go into run mode. Let's see, turn on sound. Oh, actually DSP on. Alright, 0.2. We can click 440. Back to our original pitch. Click 880. Now we're an octave higher. And click 0 to turn it off because it's annoying. Okay, so basically you see some of the simple concepts there. We've made a very basic synthesizer here that oscillates a sine wave. And you learn how you can send frequencies to this oscillator. And then you also learned how you can send amplitude information to the oscillator. Well, you're not sending it to the oscillator. You're basically multiplying the oscillator's output by a number that basically scales its amplitude or reduces it by whatever amount you're sending it. If we made a message box that was 1, the amplitude would be 1 down to -1. It would stay the same. If we had a number higher than 1, it would extend it beyond our range of 1 to -1, and it would make distorted audio. And we don't want that. So anyway, those are some of our basics. I'm going to save this as lesson 1 and save it in the folder. And then what I'm going to show you is my website and where I'm going to save this. Oh, actually, I don't need to type anything. Just hit save. The shortcut for saving is just Control S in PC or Command S in Mac. Now let me find my magnifier and zoom out. Got to call it up here. There we go, zoom out to normal view. Okay, and now I'm going to call up my website here. It's right over here, lwmmusic.com. I've recently just cleared it off and started it anew and fresh. It's got a menu bar up here. Most of the pages are kind of empty, depending on when you see this video. It could be well into the future. And it's, more things have been added. Right now, there's nothing here. You see on home, that's the main page, learning. The learning tab takes you here. And this is where I'm going to be putting this tutorial series. I'll be putting up the videos here, along with links to download what I make in that tutorial. And I'll put a little description behind it if there's any other information you need to know about it. But this is where you can find the resources and so forth as we go. And right now the YouTube page associated with this is actually empty. I made a fresh new YouTube channel, and after I upload this video, there'll be a video on it. And hopefully it'll let me add the URL, youtube.com/ I want to make it LWM Music, but it's not that right now. It's not giving me that. It's an option, so it's a really long string of characters. And so in the future, if I don't get that URL going, basically lwmmusic.com, this is where you go to, and you'll have everything right here as we go. Okay, so I'm going to sign off for now, and I'll see you in lesson 2. Okay, so I hope you enjoyed episode 1 of Learning Synthesis with Pure Data. This episode we learned our basics and our way around pure data. In the next episode we're going to look at the overtones and harmonics and partials. So that'll include the harmonic overtone series as well as partials. So you'll learn how you use higher frequency material to design different colors. And we'll learn how to make our basic wave shapes like sine waves, square waves, triangle waves, sawtooth waves, and how they're used in synthesis. So, next time, Crafty and I will join you again.